All right, so it now looks like I'm recording this session, and we're going to see how this goes. Welcome to everyone that's here. Um, as I said yesterday, L'Hopital's rule is one of those things that you guys did a little bit in Calc A. Hopefully you watched the intro video yesterday and you kind of understand the basic premise of L'Hopital's rule. What I want to show today are just a couple examples of problems that um, combine L'Hopital's rule with things like fundamental theorem of calculus. So these two examples that I have here are just examples from old practice exams or resources that mimic what you would see on the AP exam. So this first one, if I look at the limit and I try to plug 2 in, that part's approaching 0. And then if I try to plug 2 in for x there, that's also approaching 0 because the limits of integration are the same. So we don't want to say it's equal to 0 over 0. Instead, we're going to use the arrows, and then we say things like, therefore, L'Hopital's may be applied. And then once I say that, then I can actually use L'Hopital's rule. So that means then I'm going to take the derivative of the top, and the derivative of the top would be 2x, over the derivative of the bottom. Well, I have to think about what the derivative of an integral is going to equal. And that's sort of the new wrinkle in this, is that the derivative of the integral, according to fundamental theorem, is just going to leave me with what's inside the integral, in this case, cosine of pi x. And so now I have this new expression, and I can take the limit of this as x is approaching 2. Well, as x is approaching 2 now, the top is going to be approaching 4. The bottom is going to be approaching the cosine of 2 pi. Well, as long as those things are not 0, then we're okay. Well, 4 is obviously not 0, and the cosine of 2 pi is 1. So that would be equal to 4 in that case. So L'Hopital's is being applied because the top and the bottom are both approaching 0. When I apply L'Hopital's rule, the only new wrinkle is this part right here. Taking the derivative of the integral is fundamental theorem of calculus. And we just have to remember how that gets applied. So anyone have any questions on that first example?
Wait, so like you can't put equal signs to 0? Is that what it was again?
So what they don't want you to do, and I'll try and write this in red. What I learned last year when I was grading is they don't like it when you say it's equal to 0 over 0. That's what they don't like. It's okay to say that the top is approaching 0. It's okay to say the bottom's equaling 0, because then you're saying, okay, L'Hopital's can be applied. But what I learned last year grading is on the free response, if you wrote equals 0 over 0, they wouldn't give you credit for that, because really 0 over 0 is not any kind of answer. It's not undefined. It's not anything. It's an indeterminate form. So you can't really say it's equal to an indeterminate form. You can, show that both top and bottom are equal to 0, but they don't like it when you write equals 0 over 0. So that was something that I learned last year, and on the video, if you watched it, I tried to point out that even though that's what they did, that's not the form that they want you to use on the exam. It's okay to use arrows, but not equals.
Okay, thank you.
Okay?
So when you use L'Hopital's, like, do you have to write that, like, that it can be applied?
No.
Like the fundamental theorem?
You do not. You do not have to use that. I'm only using it because I want you guys to know where the work is coming from. But no, you do not have to say that L'Hopital's may be applied.
Okay.
Okay? So in the multiple choice problem, I know that the exam this year is not going to be multiple choice, but it's still something that problems like this, if you've looked at the AP classroom assignment, there are problems similar to this in the free response questions. So I figured it was still good to talk about. So for the second one, it looks very similar in terms of it being a limit and one of the two parts of the limit involving an integral. Those are indications that you're really going to be using both L'Hopital's rule and fundamental theorem. I always hate to use the word always, but I can't remember a time where a problem was written like this that didn't use L'Hopital's rule. Because anytime they're talking about the limit of an integral, L'Hopital's rule and fundamental theorem kind of go hand in hand. I'm sure I'm wrong. I'm sure there's been a problem like it where they didn't use L'Hopital's rule. I just can't think of it. So that being said, again, I'm going to start by showing that L'Hopital's can be applied, and that basically means me saying that this integral from 2 to 2 plus 0 is approaching 0, which it is, and that the bottom is also approaching 0. I'm not going to write equals in this case. I'm just going to say approaching. Then, once I can say that, L'Hopital's can be applied. And now I'll go through the exercise like I did before of taking the derivative of that integral. Now this one's a little bit more complicated than the last one, because when I take the derivative of the integral, notice that this right here is actually going to be fundamental theorem with chain rule. So I'm going to wind up with this equaling cosine of 2 plus x squared over 2 plus x squared times the derivative of what's inside, which is 2x. And then on the bottom, the derivative of x is just 1. So now as I look at this, the limit problem now becomes the limit as x is approaching 0 of 2x times the cosine of 2 plus x squared over 2 plus x squared, all that over 1. Well, you may or may not remember the trig limit from Calc A, sine of x over x. Well, sine of x over x as x approaching 0 is equal to 1. But in this case, if I now do direct substitution, I get 0 times the cosine of 2 over 2. Well, 0 times anything is going to equal 0. So I'm going to say the correct answer to this problem is 0. The hardest part about this one, and the part that a lot of people will miss, is remembering that when we use fundamental theorem, I have to keep in mind that since this upper limit is more than just x, I have to take the chain rule and multiply by the derivative of 2 plus x squared. So in the end, I wind up with 2x times that. A lot of times people are just going to say, well, I don't have that part, and I just wind up with the cosine of 2 over 2. Now that's not a answer here, but it certainly could have been.
If the first, I have a question.
Yeah.
If the lower limit of integration was something other than just a constant, like there was an x in it, would you also have to take the derivative of that?
Yes. So we did a couple fundamental theorem problems like that where the lower limit was x, or x cubed, or 2 minus x squared, or something like that. So yeah, in essence, you would have had to have done the fundamental theorem for the top and also for the bottom.
Okay.
So yeah, I don't remember if I've ever seen a problem where they combined all of that into one of these problems, but we've certainly seen fundamental theorem problems like that.
Okay.
Yep. Okay. So those were the two problems I wanted to show people. They are actually in this multiple choice set, both of them. I believe they're problems 6 and 7. There's number 6, and there's number 7. So my solutions for those problems are still available, and you can kind of see what I did. So again, you'll kind of see that for this problem, I got 0, and for this problem, I got 4. So my solutions are there for those two problems. These multiple choice problems that I posted also have a couple more that are similar. 8 and 9 are similar problems. So if people wanted to try those problems, they certainly could. I will stay on and obviously wait for people that want to ask about them. But at this point, I think I'm going to stop recording.